Today we're sitting down with Owen Nicholson, CEO and co-founder of Slamcore, one of the most talked about RTLS companies today. The assumption in tracking has always been to say, build the environment and what you want to track. Beacons, anchors, fixed infrastructure. Slamcore started from a different place. Owen, as a co-founder and CEO of Slamcore, take me back to the beginnings. Why did you build Slamcore and what problems did you envision to solve?
Oh, okay. So let's go back 10 years, which is, I can't believe it's been that long since we started this company. So it was a company that I founded along with two PhD students and two academic lecturers at a university in the UK called Imperial College. So consistently ranked as one of the top 3 universities in the world for what we do. And I was actually running the operations side of a robot lab, which I actually set up when I was previously in a role at a company called Dyson, the vacuum cleaning company. So this lab was designed to be a specialist in the world of computer vision. So the ability to take a flow of images from a camera and then extract information and data from that to allow machines to understand what's going on around them. So at Dyson, we did that for the vacuum cleaner. So the vacuum robot has a camera and that's how it understands its space. And I was so fascinated by this technology, and particularly with the team at Imperial, particularly the professor, I thought, okay, you know what, I'm gonna quit my job at Dyson in quite a good role there and moving to this small academic operations role, just because I thought this technology, it's a game changer. You're essentially given machines the ability to understand space, and that's going to be prevalent on nearly all products of the future. So honestly, when we started the company, didn't really know where the best application was going to be. All we knew is we could turn camera data into spatial information really, really well. And we started that 10 years ago with an idea that this is such a game-changing technology, it needs to be productized in its own right. So instead of building a robot or building maybe a virtual reality headset, because that also uses cameras, we thought we'll provide the core algorithmic stack and sell it to the companies who actually build the end products. So as with all things, it took a bit longer than we thought. So the first 5 years, really growing the company, growing the technology stack, raising the money, because this stuff it takes a lot of work, especially moving from more academic solutions to real world applications. So we raised the money from some amazing investors like Toyota, one of our investors. We raised money from a number of financial investors, including Amadeus Capital, who the head of that fund is what is the original founder of ARM technology, the chip company. So real great stamp of kind of approval when you have such good investors behind us. And they believed in the same vision. That vision is the future. And honestly, we built the technology and then we gave it to a lot of different companies. I'd say that nearly 200 companies in the end were using our technology at one stage. And we had drones, we had, like I said, VR headset companies, we had robots. And it was actually an interaction with the company Syneos, where we have one of our partners, and they were explaining to us how important it is that the sites, the manufacturing sites and the warehouses know where their manual vehicles are, because when they try to coordinate everything, if they don't know where that is, then the robots can actually get in the way. So we took that advice on board and realized that the technology that we had was really good at positioning cameras in these massive warehouses and factories. So over a couple more years, we pivoted the company and actually built a new product which is specifically for that purpose, tracking manual vehicles in large-scale warehouses and factories. So we've gone a bit off piece with the answer there, but that's kind of our origin story and how we got to where we are now. And fast forward 10 years from that date, we're now starting to scale the product, and we still hope and plan into the future to expand into those other verticals. But right now, our focus, laser-like, is manual vehicles in warehouses and factories.
RTLS went from experimental to mission critical. Has your vision evolved?
It's interesting. So I guess in the life of Slamcore, RTLS has only been really the last 3 or 4 years. So we're learning as we enter this market, and we're learning that the best way to enter this market is with partners like Syneos, like many others, and through the alliance that we're working with you. And I think that's as we engage with the end customer and see how RTLS is being used on the shop floor, we're definitely seeing, and even in the last year, we're only 3 years in this space, and I've seen a an evolving story already. I think there is an understanding that whilst automation and robots are absolutely the future, and that was our roots as a company, to get the most out of your site and your facility, you need to consider how all the vehicles operate and how all the goods are moved. And RTLS ultimately is just data. It gives you more data and helps you understand how your operations are performing, how the flow of goods are moving around that site. And if you don't actually know where things are at the most basic level, where is my pallet, where is my forklift, where is that human, and where is that robot, then the best you're going to get is a kind of average performance. And when you start to go in there and do studies on the actual efficiency of your assets, some of the most expensive assets are your manual vehicles. It's terrifying. I was talking to someone at Logimat and saying that 35% of the time, that's the maximum efficiency it gets out of its forklifts. So 65% of the time, they are not adding value. And that's because they only know that from doing the RTLS studies. So I would say in the past, it was maybe a nice to have, just understanding what's going on with your site. You can get away with that if you don't mind having a bit of waste in the system. But as we move towards a world where efficiency and it's important that you are able to run your operations in the most efficient way. And that doesn't mean removing people and having less people, absolutely not. Every site manager I talk to wants to do more. They don't want to reduce, they want to move more goods, they want to make more cars, but they just don't know what the current state of play is. So that's where RTLS technology really comes in.
When do you know Slamcore is the best fit? Which industry, which situation, which problem?
Oh, okay, great question. So we're getting quite good at understanding where we can add the most value and where we walk away. So I think in the sites where there's lots of outdoor and you have a lot of work going on in that space, honestly, GPS, like if you can see the sky, GPS is a really good technology for understanding what's going on there. In the indoor space, if your site is only so big that you can just look out your control tower or wherever you're sat and just have a look and you can see where things are, probably not going to add that much value. And if you've got only 1 to 10 forklifts, where we really start to see the kind of value that we can bring is in that mid to larger size sites, because our technology is infrastructure free. You don't need to have any beacons, any wires, any routers, which can cost hundreds of thousands, genuinely millions, if you've got a very big site. So it's just set up the wiring and the infrastructure. So those customers who want to take up that first step into RTLS, they don't want to invest a huge amount of infrastructure, but they have they're big enough for the fact that if they could just improve efficiency by 10%, 20%, that is a meaningful number to them. And that's probably where we really see the most value we can bring now.
Which type of projects, industries do you intentionally turn down?
Oh, okay. So the wonderful thing about what we do, so our technology is visual SLAM. So this is a general term for being able to build a map with a camera and then localize the camera inside that map at the same time. And it's like when I said, when we founded the company, we had all these ideas of how it could be used. And ultimately it will be used. Visual SLAM is going to be the building block of pretty much every machine that, whether it's autonomous or manual, if it wants to know what's going on around it, then it needs visual SLAM. So, and it's, for me as a CEO, I have to be enthusiastic and optimistic about every time I see an opportunity, because I see that and think, you know, our technology could be the right one for them. And it's taken me time to realize when we need to walk away. So in the past, we've done some crazy projects with companies like Facebook, where they built a robot which climbs across pylons, laying an optical fiber along the electric cable to connect villages in Africa to the internet. Sounds great. We got involved with that. They paid us a lot of money to build the stack for it, but ultimately it didn't go anywhere because these tech companies, they sometimes change their minds and products don't always go to market. And whilst we got money for building the core tech, and that's now helping the algorithms perform better, my big win is I'm not here for R&D. I want to have my technology out there in the wild, actually adding value, actually adding commercial value. So we've now got a good sense of when a project is being spun up because it's more R&D, or if it's really something which is not ever going to go to market, or it's not a scale that really makes sense. So as painful it is, we quite often do walk away from companies who have a really great application for our technology. So construction, mining, these are all really important for RTLS. You need to know where you're, in mining in particular, those assets can cost you $10 million, $15 million. So if you don't know where they are, that's a really waste of time. And technically, our product could solve that problem. But right now, we are laser focused on warehouses and factories, because that's where we can get the scale. And then in the future, oh, absolutely, yeah, you'll see us everywhere.
Looking back now, what did you initially think customers would need versus what they actually needed? Was there a delta?
Oh yeah, really, really interesting question, because we essentially we founded the company very technical. I'm not a SLAM expert. I did physics a long time ago, so I can just about conceptually understand what's going on, but I'm not a technical expert at all. I have people in my team way more qualified than us. But the original proposition was a very technical sale. It was a software SDK, so you would actually sell to the technical teams within the company, and then they would integrate it, and they build a full solution using that technology. And we thought that's what the market wanted. You've got a technology which is applicable to lots of different spaces, so let's sell it as a flexible toolkit so that technical people can take it and build amazing things. What that actually ended up doing is providing a toolkit for R&D teams to build demos and fun things, but never, very rarely take it through all the way to commercialization. So we made a very important decision that we would take that amazing technology that we built, and we'd actually put it in a box. And that's what we have now. It's in many ways not as exciting. It's literally a black box. You sell it as a complete product as opposed to a technical algorithmic stack. And with this, the great thing about this product is I can go on a site, I can install it retrofit it on a forklift that's operating in that environment right there. And by the end of the morning, it's actually adding value. And that is something which is really important, because whilst I love the AI and this amazing AI going on there, the customer doesn't care. They just want to know what is going on the shop floor so they can start adding value as quickly as possible. So that's probably one of our biggest lessons that we've learned. Technology doesn't mean product. And when it comes to engaging with the customer, moving from projects, away from projects to just an actual sell. You wouldn't do a project buying a laptop. You wouldn't do a POC buying your office chair. These are products that you buy, and if you like it, maybe you get a week's free trial, and then if you like it, you deploy it. So being able to pivot from a very, very technical sale to a very simple sale, and I hate sometimes saying that, because this is like, it's taken us 10 years to build the technology, but at the end of the day, the sale has to be super, super easy, even if the technology is super complicated.
When organizations run multiple RTLS across sites, what breaks in the scaling?
So I think quite often there are different RTLS have different benefits in certain areas. So if we look at a large factory, they might have RFID using RFID gates to understand where the stock actually is. They might have robots using LiDAR-based RTLS to localize themselves. You might have AGVs localizing themselves by using magnetic tape on the floor. And then, of course, hopefully having cameras, having forklifts using our product to localize within the same site. So all these different technologies ultimately exist to provide two numbers, and that's the X and the Y coordinate of where that thing is at any point in time. So if you have your floor plan, all the RTLS technology is doing is telling you where is that thing on your floor plan. That in itself isn't valuable. That is just dots on a map. And dots on a map doesn't really give you anything apart from maybe a nice dashboard so you can feel good about yourself knowing where things are. But how does that actually affect your decision making and your operational workflow? So if the RTLS technologies are deployed in a black box, and I mean that not in the physical sense, I mean in the way that if they don't have open APIs, they don't have simple ways of communicating. VDA 5050 is a great example, but there are some sites that don't have VDA 5050. So if you only do that, then you can't work on those sites. So I think the biggest thing that we've learned is if you want multiple RTLS technology, that's fine, but you need to have a sensible way for all that data to be aggregated in a central way, and for all those XY numbers to be presented in the same coordinate system, and for the timing to be the same. So then if you're going to do any analytics or any in real-time management of that information, it's real-time, it's meaningful, and it's coordinated at that kind of level. So
When RTLS genuinely transforms how people work, what does that look like for a customer?
So what's really exciting, we're starting now with our deployments, and also RTLS has been around for a long time, so we can look at historical RTLS. There are other ways of tracking forklifts, and they might be more expensive, but you can still see how they've added value to those companies. So I was reading some really interesting reports about some of deployments of RTLS for forklift tracking using an alternative technology, but the value that they delivered was still incredible. So there was one site that got a 50% increase in productivity. So as far as picks per hour, the workflow went up by 50% because now they were able to understand where their assets were and be much more efficient in the way they used them. Another one was 20%. And the great thing about that is when there's a driver on the back of that forklift, you're paying them anything. Let's just use a round number: 50,000 euros, dollars, GBP, sterling, 50,000. If they're paying them that per year, all in, if you just make them 10% more efficient, you're delivering $5,000 a year in value. And as long as you charge less than $5,000, that's a great return on investment. So I think that's a really nice way to show the transformation. And we're also starting, now that our camera on forklifts, we can also detect where the people are because we have a camera and we have lots of AI that can do perception. And then we can alert the driver if they're on a collision course with a person. So again, there are lots of pedestrian detection technologies out there, and we're starting to see it with our customers that you can actually reduce incidents by 20, 30, 40%. And these are, you can't put a price on a life, but it's also reduces serious accidents, and that's a really incredible thing that you can get with the same technology.
What is the one thing that has consistently surprised customers about RTLS in your many years of experience?
So I can't speak about all RTLS. All I can do is talk about my technology, and I can tell you what surprises them about our technology. In fact, one of the partners we're working with from one of the top consultancy firms literally said, this thing is like magic. So our technology is able to go into a site it's never been on before. We mount it on a forklift, we turn it on. It takes about 15 minutes to set it up. So you do a very, very quick loop. Don't have to go up every aisle. You can only do 10, 20% of the sites. Turn it and click save, and that's it commissioned. And that's something that the industry just isn't used to. They're used to it taking weeks, months to set up the infrastructure. Even with LiDAR, it could take you an entire week to get the scanning right, to get a map which you can use as a baseline. So I think that's probably the thing that seems to be surprising our customers the most is it's possible to get centimeter accuracy RTLS with 15 minutes of commissioning. And I love, my favorite thing is going on site to a shop floor. They ask us, how do you want to do the meeting? And I say, on the shop floor, we will do it within that. We've only got an hour because that's as much time I can normally get with the execs. Just give us an hour on the shop floor. By the end of that, you'll see a working system with a dot on a map. And this will then be something you can plug into your wider RTLS system. And that is something I always love doing because it always amazes them.
When RTLS projects fail, what's the real reason? Sounds the official jargon.
Oh, so if the customer isn't really bought into the idea of making efficiency gains, like there is an interesting kind of tension sometimes in these types of projects because no site manager wants to admit that they've got massive waste in the system. So if we come out and say, talking the person I talked to earlier, who said that they are seeing that their forklifts are only actually productive 35% of the time, there's an argument to say that like, why has something not been done about that already? So sometimes there is genuinely, if projects are started or people are doing this because they're forced to and they're not engaging it, or it's a top-down thing where the execs have said, all right, you've got to implement this technology, that is a recipe for disaster. So that's probably one of the biggest things. If you haven't got buy-in from the workers on the ground and the people who are actually running the site, who actually genuinely want to make things more efficient and safer, then you might as well just give up and walk away.
What's the one barrier to global RTLS interoperability you would want to eliminate?
Oh, good question. So the one barrier to global RTLS interoperability, so it probably comes down to standardization. It's a bit of a mess. There's a bit of a wild west out there with different RTLS technologies, different standards. And I'm actually not in the camp of complete strict standards which everyone must follow. So the VDA 5050 is great. It's something that allows a baseline for everyone to communicate. But it can't be so rigid that you can't allow other modalities, wrong word, but other ways of sharing RTLS data to last. And particularly in the US, VDA 50/50 isn't really being widely adopted. In fact, the entire model is actually being pushed against. So I would say standardization is really important, but there needs to be flexibility within that standardization so that we're not, that there is the ability to not absolutely prescribe exactly how things need to be done.
Are you already harnessing AI for RTLS? And if yes, how?
That's a great question. So I think we've been doing AI for since before it was called AI, and there's been a kind of a different definitions along the way. So it used to be machine learning, then it was deep learning. Now we're moving into a world of foundation models, and of course, world models is the biggest thing right now. And for me, I see AI as the type of algorithms that learn and are trained on data as opposed to handcrafted by in kind of more the old school way. And there has to be a balance between the two, because the handcrafted algorithms are going to be more reliable and safer ultimately, and they tend to work better in more generic situations. But with the learned models out there, it's amazing what you can do. So we do use a lot of learned models within our system. The system we have right now has an NVIDIA GPU on board, so we can run AI till the cows come home. And the type of AI we run is pedestrian detection. We can tell if there's a person in the field of view. We're also building models for detecting vehicles, being able to tell if there is other objects within that space. And because we know where the camera is, we then also know where those objects are. So that's a great example of how we're using AI right now. And I think as we look forward to the next generation of AI models, foundation and world models, the only way we're going to be able to build these models is with huge amounts of rich data, and it has to be real world data. So the LLMs like ChatGPT and those kind of clouds, they've been trained on vast amounts of words because the internet is at our fingertips. If we want to build industrial models, we need visual data from industrial plants, and that's extremely hard to get hold of, because why would a site manager let you put cameras out there? So we're finding actually the data that we're capturing from the product we sell today, which we're not selling AI to these guys, they just want something that works, but we're capturing this data that's going to allow us to understand what's going on the shop floor, have camera images from every single angle you can imagine. We're going to have 10,000 of these units out in the wild soon. And that data set is going to be essential for training the next generation of foundation models and eventually world models, because we have so many different viewpoints of the same site. We have spatial information about where that camera image was captured, so its coordinates, the speed that was being driven at, and also whether the human has intervened on that forklift, because we know if they hit the brakes, if they done a sharp deviation. So I'm really excited about the future of AI, because in the past, it's been something that has been very hard for companies to get access to unless you have the $1 billion of the big tech companies. But we're building a platform now which is able to capture the scale of data that's going to be required. And in the future, yeah, I think the algorithms that we're going to build are going to just be, just like there was this, when the ChatGPT really started going, we were amazed at what was possible. I think in the next few years, we're going to start seeing some AI in this space, which is just going to be something like you haven't even thought of yet. What I can tell you is you're going to need the data, and that's exactly what we're capturing now.
Which AI capabilities remain aspirational? What's the gap between marketing and reality?
I'm going to talk about the elephant in the room probably in this space, which is probably the humanoids. So I think humanoids are amazing at what they're doing right now, and there has genuinely been a step change in capabilities. So I remember over the last 10 years, I've been going to robotics conferences, seeing these academic humanoids, everyone clapping because the thing took one step or two steps and didn't fall over. And all of a sudden, in the last probably 12 months, we're seeing robots doing backflips. We're seeing dexterous motion, manipulation at a scale which we thought was decades away. So I think the humanoids are very exciting, but the challenge is, where is the real commercial application and the real value that they can bring, especially if they can't walk from one side of the factory to the other. And they are going to need RTLS. This is local manipulation is great if you're sat in a chair or in a booth doing packing or assembly. And doing backflips is quite useful if you need to, actually, no, I have no idea why you need to do a backflip, but if you want to have a circus robot. But in a factory, there's no needs for that. You just need to get from A to B safely without crashing into things, which is a classic problem for robotics. So I think there is definitely a hype for robotics. I'm not on the bandwagon of saying these are going to be deployed at anywhere near scale in the next few years. there will come a point where they will, and it will probably happen. It will happen. It'll be one of those things. It feels like it happens overnight, but I really don't think we're very close to that happening right now. But back to my answer previously, for these humanoids to really be able to do that, they're going to need to be access to vast amounts of data. They have lots of data around manipulation, but they don't have general data around what's going on in the shop floor in these sites. So I'd say that's probably where there's a current gap between hype and what's actually applicable. The humanoids can do amazing things. Can they actually add commercial value? I'm still yet to be convinced. But if they can, then I'm pretty sure I'm going to have a local RTLS solution I can sell to them, because that's exactly what we're building.
What stops companies from actually scaling RTLS beyond pilot projects?
Yes, okay. So I think one of the challenges of scaling past a POC is quite often, especially in a lot of the innovation labs that I'm constantly having chats with. But sometimes you realize that the way that they're building their POCs, they're very siloed and segmented. So they want to test one specific RTLS technology, or they want to understand this one robot, how it helps with this one specific thing. And the reality, that's not how these sites work. They are hugely complex sites with things interacting at every single possible level. You've got robots, humans, forklifts, you've got conveyor belts, you've got safety systems, you've got all these different systems that need to interact and communicate in some kind of way. So if you do a POC which does really well in its one specific environment, the moment you start to try and scale it to any form of a kind of larger deployment, you start to run into the barriers of the fact that actually it might actually have a negative effect on some other parts of the workflow. A classic example is robots. Robots and AMRs in the factory and warehouse add a huge amount of value when they're locked away in their own little area. But when they start operating in the same space as the manual forklifts, they actually slow down the forklifts and create a negative return on investment on that really important asset. So I think if a POC is so siloed and so specific to that one technology or that one product, then it's going to be very hard to scale. So these innovation labs need to think much more holistically and pull together POCs with multiple parties, proving how these things actually work at scale, instead of trying to do it at one little step at a time, because that's normally destined for failure.
If a customer asks you, should they buy from you directly or a local partner, what do you tell them and why?
So we are relatively small. We're only about 40 people. So we definitely rely very heavily on our partners. So we have an extensive partner network of over 15 companies now. So we always encourage our customers to work with the partner, because they are normally set up in country. They're able to provide the support. It's also good for us from a commercial point of view. We can have one relationship when they can sell to many, as opposed to trying to sell to hundreds of different end customers. So normally I would encourage the customer to talk to our partners, but we can also, if they want to just try the technology, we can work with them directly. And then once they're happy with the core RTLS proposition, we can introduce our partners to help them scale.
What does the autonomous enterprise look like in 2035? What do you envision will be RTLS's role?
Oof. So in 2035, we're probably starting to talk at the scale where the elephant in the room, humanoids, are actually going to be able to start to add real value. So I think the future sites RTLS is going to be even more important, because you're going to have so many different. You'll probably have drones, you'll have humanoids, you'll have AGVs that go on the floor, you'll have monkey robots that climb the shelves, and you'll have humans. Humans are not going to be removed from this equation, because humans are still the most dexterous, the most intelligent things that we can deploy on these sites. And there may be different types of roles emerging as you need to coordinate these different types of autonomous systems. There are going to be people, there are going to be manual forklifts. So the future sites are going to be really cool. I'm excited to see what this looks like. But the need for RTLS and the need for sharing this positional information in a real-time and simple way is going to be even more important, because otherwise we're just going to have chaos. We're going to have a dangerous place for humans to operate, and we're going to have robots and machines crashing into each other on a daily basis.
How do you see your support of the RTLS Alliance helping end customers and the industry as a whole?
So I've said a lot during our chat. The key to RTLS being rolled out at scale is about the partnership and the ecosystem. We do a part of the problem. There are other companies that provide the other parts of the problem. And it's very rare you're going to find one or even two companies that can deliver your entire system. So the RTLS Alliance for me is really important, because even though we might compete with some of the other technologies within that system, ultimately we are all trying to provide value, or turn spatial data into value. And the RTLS Alliance is a perfect platform for us to engage with both suppliers into that into that ecosystem, but also buyers who understand and appreciate the fact that they are not that the ways that they get what they need is by working with multiple companies. So I'm really excited to be part of the RTLS Alliance. I think it's a really great endeavor, and I'm excited to see it grow.
Do you intend to address any industry-wide adoption blockers through the collaboration with the Alliance? If yes, how?
I would say we've got to speed up the procurement process. It's just ridiculous. It can't take 6 to 12 months just to get onboarded onto a system. So I'd say like that's probably a really great way of thinking we can work about other ways to fast track smaller companies in particular when it comes to IT security, cyber security, things like that. Can't take shortcuts at all, but going through some of the ISO standards and things like that for a smaller company can take years. So I'd say it's not a technical problem, but it is a genuine barrier to adoption is the time it takes for customers to actually buy and procure systems from smaller companies. If we can figure out a way to make that smoother, that's going to be good for everyone.